Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my BEng Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Okay, so question 4, 2013, also on paper 1. Michael has a credit card with a credit limit of 1,000. Interest is charged monthly at 1.5% of the amount owed. Michael gets a bill at the end of each month. At the start of January, Michael owes €800 on his credit card. If Michael makes no repayments and no more purchases, show that he will exceed his credit card after 15 months. Okay, so interest is charged monthly. Okay, so that's typically compounded interest. Okay, which normally flags this compound interest formula here on page 30 of your log tables, okay? Okay, so the interest rate is 1.5%. Okay, and as your log tables tells you, and we've been practicing, that has to be written as a decimal, okay? So 1.5, if you divide something by 100, you will write a percentage as a decimal, okay? And at the start of January, he owes 800. So that P in the formula is what you start off with. It's called the principal amount or the starting amount. And show that he's making no repayments, so he's not trying to pay off his loan at all. Show that he will exceed his limit of 1,000 after 15 months. Okay. So perfectly fine to use that compound interest formula, even though it mentions years up here. It's perfectly fine to use it for this as long as your time is in months and your interest rate is in months. So the time base has to match, and as long as it matches, it's perfectly fine to use it. So F then is equal to 800 times 1 plus 0.015 to the power of 15. Okay, so let's put that into our calculator. And I'm getting 1,000.18565. And because it's money, it has to be 2 decimal places. So I have to look at that one, and it's going to round it up to 19. So €1,000 and 19 cents. And I would say €1,000 and 19 cents is greater than €1,000. Okay, so that's you shown that it has exceeded the limit of 1,000. And then part C, Michael bought an item costing £95 on the internet and pays with his credit card. If the exchange rate is €1 equals pounds 0.8473, calculate to the nearest cent the amount that will be included on his credit card bill. Okay, so the official way of doing these is you write down your exchange rate, 8473. The amount you're exchanging is pounds, so it goes on the pound signs, and you can put a question mark or an X there for the euro. Okay, and what you do is you end up cross multiplying. Okay, so you will get 0.8473x is equal to 1 times 95. So it's equal to 95 times 1 if you want. Okay, and then I divide both sides by the number in front of x, so that I get x, the euro amount, to be equal to 95 divided by 0.8473, 112.12 euros is what I got for that. Okay, so that's the official way of doing it. There is an unofficial way of doing it, and that's as follows. And it's more the logical way that you would do it rather than the maths-based way. You'd look at the exchange rate and you figure out, are things more in euro or more in pounds? Okay, and because the euro is bigger, that's 1 versus 0.847, then I would say if I'm going to get a euro price, it's going to be bigger than my pounds price. Okay, so then if you have something that costs £95, is the euro amount going to be bigger or smaller? Well, it's going to be bigger in euros. Okay, with an exchange rate, you're always either dividing by the exchange rate like we did here, or you're multiplying by this exchange rate, okay? So on your calculator, if you try 95 multiply by 0.8473, it's going to make the number smaller. So you know it's not a multiply. So then try 95 divided by 0.8473 and you will get a bigger amount, and you know that's the right way. So if you find it difficult to lay out the exchange rate formally like I have here, you can try the more common sense method, which is here, which is figuring out which gives you the bigger in euro. Okay, but the formal way I have here, as long as you keep pounds under pounds and euros under euros, then this should work out too. So it's whichever makes your life easier and helps you to work it out.
If you are interested in technology or engineering, but are not doing higher level maths, why not consider our Level 7 in Electronic and Computer Engineering? This is a 3-year programme that looks at the design and development of embedded electronic systems. These are the medical devices that keeps us healthy, the consumer devices that keeps us entertained, or the controlled systems that keeps us safe on the road. You can then progress on to the Level 8 in electronics and self-driving technologies, and from there to the Masters.
Check out the link below for more information.